Hi, this is a video about some work I did in third year. It was a networked raycasting thing. It was for our networking module. So I've launched a server, it's listening on port 1177. I've got two windows open here, and you can see when I'm controlling the right one here, and I've got a little sprite that's moving around in the other window. So this is communication done by UDP, and you can see the server is currently printing out what's going on. It's got two clients connected with IDs 1 and 2, and it's just spamming out their position and velocity and rotation and stuff like that. So looking at this code again was kind of interesting because even though it wasn't, I mean, it's been a year since or a bit over a year, I think a year and a half. There are some interesting things about the code. I had some interesting ideas, which I'm not sure if were necessarily good or bad. They were worth exploring, things I would do differently now, for sure. But anyway, while the code itself, looking back on it, I can see a lot of things I would do differently. This does have quite a few features in it, and I spent quite a lot of time working on this back when I was doing it. So right now, this map we're looking at, I'll explore it a little bit. It's a standard grid-based Raycaster type map with some textures and stuff. This map is hosted by the server, and when a client connects for the first time, they download the map data. And that is done over TCP. So the server makes a connection to the client over both TCP and UDP, and it's only the real-time gameplay type stuff is sent over UDP, and anything that's like critical can still be sent over TCP if necessary. You can see I've got some prediction and stuff going on, although the prediction is not quite working. When I move to the left, it's over predicting, and then when I stop, it interpolates back to where the client actually is. Probably some problem with the vector class that I wrote at the time. But the interpolation and stuff seems to be working quite well. It's just the estimation of how far to predict is pretty off. It's pretty funny looking at it. You can see each client has a flashing red square in the top left, and that was just to indicate when they received the packet for debugging. Anyway, let's cancel this. So if we take a look at the main here, you can see I wasn't quite sure if I was writing C or C++. We got quite a lot of C-style stuff going on here, and yet I was also making use of some C++11 features at the time. This is when I was just learning about the smart pointers introduced in C++11, so I was keen to learn about them and use them. Code down here is not the worst in the world. It's not clear what's going on. This could obviously be reorganized a lot. I've got a lot of classes here, so like some of the stuff I was doing in a C++ style, and then there's these like random C-ish elements being thrown in, and it's, as I said, a lot of stuff I would do differently, but it worked at the time. I guess it's kind of inevitable whenever you look back on old stuff that there's going to be something differently you do. So this is the main in the server, and you see I've just got the map data hard-coded here, and this is what's sent to the clients when they connect. The server is a lot simpler. So you can see I had the unique client code organized over here. I had the unique server code here, and then I had a bunch of shared code, which was this defines all the packets that are being sent to and from the client and server. So again, like on reflection, there are problems with this design, but this is what I thought was kind of interesting when I look back. So if we head over to the base packet, I suppose, what I did, so the packets internally are just an array of bytes, and every packet, the first byte of that is the packet type. And so we've got a uint8 enum. Everything after that is unique to each packet. But what would happen when the client or server received a packet? It would receive it into this universal packet, which was just like a generic container. And then I would call this create from contents function that would read the first byte of the packet data, and depending on what the packet type was, whether this heartbeat was just like a keep alive, like the client isn't doing anything, but they're still there, so send a heartbeat. Then you've got join request, join response for when clients connect, info request, can't remember what that did. Map data, that was the type of packet that was sent over TCP. So all of these packets can be sent over TCP or UDP. The move packet for when a player moves with their velocity and such. And this is when a player actually, so they make a join request and there's a response, and then when they actually joined, this packet is sent, and the disconnect packet sent here. And then the sync packet is to sync the clocks between the client and the server. So there was some estimation done about the time of flight for packets between the client and server, and that would then the client and server would attempt to synchronize their internal clocks. Anyway, so you can see in the switch statement, I read the type, which is the first byte, and I then new in a heartbeat packet and call construct packet, which does a mem copy into the newly created packet. What is there anything else I would like to talk about? Oh yeah, so the libraries I used for this were SDL2, which I've done quite a lot of stuff with, and SDLnet, SDL2net, which I'd been wanting to learn for a while. I ended up using that because it would supposedly work well with SDL2, and it would be cross-platform. I ended up having to work around a bunch of the features of SDLnet, and in the end it probably would have been easier to work with sockets directly, just because of the way I was doing things in my universal packet and casting and whatnot. Anyway, I think I'll stop there. I would like to come back and have another go at a little networking something. It wasn't really a game. I'd never really implemented any gameplay, but it was kind of fun to look back and see what I did. Hope that was of interest. Thanks for watching.